So this week we're already running like 15 minutes behind, so we're just gonna run quickly through this. So I like cat pictures this week apparently because I found a lot of them. Okay, quickly announcements. Shakey's fundraiser tomorrow night.
I got the wrong.
What?
1800? I was looking for 6.
It's 6 o'clock.
6 to 9. 1800 West Covina. And then
No, that's the time.
No, it's the time.
That's the time. I just put West Covina, so it's at 6 o'clock at the West Covina Shakey's. The address is
It's on the board.
on the board.
Yes.
There. Yes.
Yes.
Sounds like a principal call.
So if you guys like what we do here, and you like having free pizza each week, then it would be really awesome if you came out. We're going to be doing fun things, social interaction. I know for some of you that might be challenging, but still we would love to have you come out and talk to us and meet us and help us raise some money for the club. So please come. This Friday we will be having the Red Team workshops, which I've talked about before briefly, but basically what we're going to be doing is we will be teaching you how to survey a network and basic reconnaissance of a network, the things that you need to do for CTF or a red team at CTDC. So if you're interested in that, please RSVP by email to swift@csupomona.edu. Yes? What is that email?
Yeah.
Yes, that's the correct one. The one on the flyers. We have 2, that's why. So yeah, it's bring your own dinner. And it is members only. If you are not a member, do not fret, it is not too late. You can still pay. We have a sort of a pro-pay plan where you don't pay as much because you're joining halfway through the year. If you are a member, this is one of the benefits. We don't always cover those very well, but you know, you get to do the cool stuff. So if you want to become a member, come talk to me. And if you are a member and you want to go to Red Team, please email. So, okay, so briefly, this is the slide that I'm going to have to cut short. I just want to talk about the future of Swift because we're doing a lot of stuff. If you are interested in being a part of eBoard, so if you're interested in helping run Swift, even a small part, we can probably fish you in. What we will need to do is start doing eBoard shadowing. Basically, if you're interested in becoming treasurer or secretary or director of marketing, you'll need to interact with the people who are doing those positions right now to get an idea of what they're like. So if you're interested, come talk to us or again, email us. Because we'll be holding voting for eBoard. I forget when it is next quarter, but it's next quarter. So it's, I don't know. And then if you, also we're going to try to be getting in some speakers from DEF CON. So hopefully that should be really cool. If you have a topic that you want to see, something you don't know very much about, something that we don't cover, please let us know. Because, you know, there's only so many of us, we can only come up with so many ideas. We want to know what you want to know. So please tell us if you have a talk that you'd like to see. And then if anyone knows a graphic designer, we're thinking about revising the logo, and we're looking for a graphic designer to donate their efforts. So next slide. This is the new logo that we were considering.
Oh yeah.
But it's got some things that we need to work out with it. So
And it's copyright.
right, probably shouldn't use the one on the actual truck. So go ahead.
So we changed like
Okay,
the colors.
so this is something new that I'm going to do. I'll cut this short, but I wanted to bring up some cool things in the news this week. The first one is that Google Wallet's been having a lot of troubles. So all the links are in the slides. We'll put those up. But basically Google Wallet is not secure.
Yeah, I got compromised, so yeah, I know that.
What is?
Oh, you actually got compromised?
I got an email, I got a phone call from my credit union saying, like, your debit card was used for Google, like that. Like, that wasn't me, so.
Wow.
Yeah.
Yeah, so right there. And then, man, that's hard to read in these lights. That's the Large Hadron Collider to run at 4 tera electron. A large number.
You mean 14?
No,
that's a 4. It's just a really blue 4.
You should see 14. It's 14.
It's 4. It's not 14. 14 would be incredible. And that's a really cool article. And then MITx, which is something like OpenCourseWare, apparently. But they're running a curriculum that is all about circuits and electronics. So that's really cool, and you should check it out. I think there's one more up there. Oh yeah, so for the talk this week, we have Arco, and that just brief introduction. So he's another electrical engineer like myself. He works really cool places, and you should talk to him about it. And he's also part of NSL. We work with NSL a lot, and their website is here. And then, of course, myself is speaking. So we're going to go ahead and switch to the presentation here.
Yay.
Also, if anyone needs a ride to the fundraiser tomorrow night, then talk to myself or Erica, and we can give you rides. So. Okay, so briefly, what we're going to be talking about today is the project that Arco and I have been working on. I call it Auto RC, he calls it Vision Bot or something like that. We're still working out the name. But basically, it's designed to be a robotics project that focuses around computer vision and navigation. Why would we be interested in a project like that? So basically, consumer level technology has been progressing rapidly, and it's finally starting to bring the price point down of some technology that is incredibly useful in navigation and robotics. So the purpose of this project really is to pick a hard problem. Navigation is not easy in robotics. As humans, we do it every day and we don't really think about it, but it's actually pretty hard to do well. And that's what all those autonomous car competitions are about. And so, really, we wanted to pick a hard problem that is achievable with fairly cheap technology, which is good because we're both college students, and so we have no funding. And then the small, cheap solutions scale fairly well. As in, if you can do something small and cheap, you can generally do it for larger on the same price point. So the basic idea, like I said, is a small RC platform that does navigation and some simple tasks. The RC platform that I chose initially was this RC car, which is because I had it in my garage. Again, we were trying to do it on a college student budget. So, next. So one of the things that a navigation robot needs, besides a mobile base, is going to be sensors. How does it interact with the world? So some of the sensors that we were talking about putting on would be GPS, or an inertial measurement unit. That's accelerometers, gyroscopes, magnetometers, which measure different things about motion and position in 3 space. So basically using a 3-axis accel, gyro, and magnetometer, you can have a really, really good idea of where you are in 3 space. And if you combine that with a filtered GPS signal, then you can get a really good big picture idea. So not only am I moving in this direction at this rotation at about this speed, but I'm in Kentucky, which is really sad actually. Yeah, like I said, integrated, they provide really good information looking. So initially to start this project, I was like, okay, I need a base platform, I need to move around. How can I do that? So using the RC card, it turns out that RC cards just use pulse width modulation pins, which is really cool. You should look them up, but is kind of beyond the scope of this talk. And so basically, you just write a PWM signal to the PWM pins, and it provides information to your servo or motor to make it move or go. So in the case of the RC car, one servo controls steering left and right, and the other controls forwards and brake. It doesn't have reverse because of the nature of RC cars. You don't really care about going in reverse. You just want to go fast forwards. And so, and this is a better picture of the RC car platform. I don't know how much longer we're going to be sticking with that because it's kind of small, but I just thought it was interesting. So, you know, if you were interested in doing a similar project, there is lots of things out there that are easy to hack and access and use. So, image processing. The Arduino, which is what I was using to control the RC car, is not powerful enough to do OpenCV. OpenCV is a free library for computer vision. That's where the CV part comes from. And it basically can take any sort of image that you give it and process it using a variety of tools, which I will talk about a little bit later. And I knew that, okay, did I miss a slide about... My slides are out of order, that's cool. But basically, I had to make a decision about how I was going to navigate. Touch sensors aren't very good because by the time you've touched something, you're already up against it. Physical contact is not something you want in the robotics world. You can also use laser rangefinders. Laser rangefinders are cool, except it only gives you a single data point. It only gives you at exactly this point, this is how far you are from an object. And so it was pretty clear that we needed to use a camera. And so I knew that the Arduino was not powerful enough to process the information coming in from a camera. And so I needed something more powerful. The next step up from an Arduino would be something like a BeagleBoard or a pandaboard. My choice was made for me. As I told you guys, I received a pandaboard for free, so that was kind of a no-brainer. I was like, well, I'm just going to use this. So, next. So this is a picture of the pandaboard. I'm going to briefly talk about what it is and how I'm going to use it. So, next. Pandaboards, they are dual-core ARM processors with up to 1.2 gigahertz per core. So it's about the same processing power as most netbooks. It's designed really for full HD encode, decode at 1080p. The pandaboard ES, which is the model that I have, actually is designed to do full stereoscopic 3D 1080p image processing. So it's basically designed to output 3D at 1080p, which is incredible. So it has a really fast graphics core. It also has a gig of RAM. It's DDR2, but it's really, really low power. The whole pandaboard runs on about 5 volts, which is incredible when you think about it. It's basically just a computer on a chip. The TI Texas Instrument chip on there is an OMAP 4, which is a part of their family of SoC chips, system on a chip. Chip, yes. It's redundant. And so those are, it's designed to be an all-in-one thing. And also it does SD cards. So when you put in an SD card, that's the hard drive, essentially, is you have like a 4 gig or an 8 gig, you put an operating system on there, you plug it into the system, and that's your hard drive. So, next. Which is awesome. Pandaboards are delicious. So, pros and cons, briefly. Pros, it's very powerful, very flexible, and has lots of input-output. The board itself has access to things like I2C, serial, you can do debugging with JTAG. There are really cool hardware aspects of the pandaboard, which makes it great for developers. The cons are it's kind of expensive. So on my budget, this is perfect because I had received it for free, but retail they're about $180, so that's not as accessible. A BeagleBoard is more like $80, I believe. The lower end BeagleBoards are $80, so that's a lot more accessible. But pandaboard is more in the power range that we're looking for. So, and it doesn't have as big as a community. What I've learned very rapidly is that it's hard to get started with the pandaboards because there isn't that many people who use them yet because they haven't been out for very long. So, so here was the slide that was out of order. So should we go camera or kinect? Well, one camera is not enough. It's kind of like holding one eye closed and running around at top speed. It doesn't work very well. You don't get enough information about how far away things are from you. If you use two cameras, that's very similar to the human vision system, and that's great. Unfortunately, by the time you have bought two cameras that are of a decent resolution, you can just afford a Kinect. For those of you who aren't familiar with the Kinect, I would be kind of surprised. It is Microsoft's, yeah, this is what the Kinect looks like. And it's Microsoft's, you are the controller system. So basically it has really good depth imaging, and it does color images, grayscale images, depth images, and a colorized depth image. That was the 4, right? And so you might as well just use Kinect by the time you're going to purchase two cameras. So, which is better anyway because you get a depth map. Yes?
And I was also just going to bring up, also when you get the Kinect, you can use it for any other project as well, because they're so hacked now that
Right.
you can use them for anything.
Right. Yeah. So at that point, at least me, computer vision.
Before I start, I don't know if anybody has a DVI cable on them. I have one in my car, but I don't have one here. If there is one, we can do a better demo later, but it's not. So we're going to talk about. I'm going to talk about computer vision, robots, and beer. For the next. So what is beer? Beer is amazing. If you haven't had it, it's delicious. The idea started about 2 years ago at DEF CON. The idea was to have a robot that drives around with beer and you wave at it and it'll come at you and it'll give you beer. It's awesome. So one really awesome thing is the Kinect, which has skeletal recognition. So you can be like beer and it'll be like beer. So beer's great. Anyway, next slide. That's not about computer vision. So what is computer vision? So the way this works is you have a vehicle, you have these sensors, you get sensor input, you update a state model, and you know where you are, and then you act on it. So up there you can see there's many sensors you can get. You could use stereoscopic cameras. You could use LiDAR, which is usually pretty expensive. Like that 6 sensor up there is a couple 10, maybe like 30 grand. And then you run it through some algorithms. So you can see this is Stanley, which I don't know if any of you guys saw the DARPA Grand Challenge, the car that drove itself through the desert. They did the urban challenge that drives through cities, which is even scarier, and a lot harder. And then you can see like that one is there's the camera, and then they've overlaid laser, done some color recognition, and recognized what is road and what isn't. Like the sky isn't road. And then later, this is what the computer thinks it sees. And as you can see, there's like buildings and people walking, and there's a path it wants to take. So now you know where you are and where you want to go. This is a little scary, because if you're going to sit in the car and you're going to say, take the wheel, it might drive off a cliff because you forgot to put like a minus sign somewhere. And it's a really simple case, but obviously you really want to trust the code you write, and you also want to know, how trustable is the code you write. So it's a lot of testing that you have to do. So what's out there? This is kind of diving into what Zach and I started doing. We looked at hardware, and we can't afford, like that little USB LiDAR, which is probably the cheapest you can buy, is about $1,000. And that's like the entire project's budget, which is ridiculous.
It's $1,000 more than the project budget.
Oh. Yeah, that sounds about right. Yeah. So we, a couple months ago, I ended up buying a Kinect and just messing with it. I didn't really have time, and then I came back to it finally. But the Kinect has solved a very, very difficult problem, and that is obtaining depth image for cheap. Cheap is the hard part. The way it kind of works is it has a little projector, an IR projector that projects a pseudo-random pattern, and it then has an IR camera which picks that up And from there, it goes through a bunch of algorithms and figures out where the depth, how far away things are. It gets much more complicated, far beyond the slides. But that's what it does. And it's cheap. It's like $150, and I bought it at $99 at GameStop that was used, and it was beaten up, and I really didn't care because it worked. And you know, USB cameras, you can buy them anywhere. So what's the software that can handle all this? If you have like a USB camera or the camera built into your computer likely, you can use OpenCV. It was developed by Intel. It is now become open source. I think it was open source to begin with, I don't remember. But it's a great library. It's seriously like, you know, video capture object, you know, start it, choose which device you want, and there you go. You have an image, and you can start working with it. And there's tons and tons of tutorials and support pages out there. So that's good for doing image processing, but for the Kinect, Microsoft released their SDK, and it's very meh. Is the way to put it. Because it's not, it's just meh, alright? But there's really, really good hacked firmware, oh no, not firmware, hacked software that works with the Kinect. OpenNI, and I think there's free libconnect. It's cross-platform. It could be Linux, Mac, Windows. It works great. It gives you tons and tons of data, everything you'd ever want to get from it. And then another thing is OpenPCL, which stands for Point Cloud Library. And this kind of gives you a way to take that information of depth and put it into your code and actually save it and have it somewhere, like, you know, hold that data of depth that you have. And you can hold it in a 3D field, like, you know, open up OpenGL, import the point cloud, and now you can rotate this and look at it. Next slide. I'm going to dive right in. Usually in these sort of like lectures, I always want to know how they did it. So I'm just going to tell you one really simple way, one simple example that I did. And you can do this on your own. You can in fact do it with your laptop through a web browser. I have the links at the end. You can do it later on your own. So an OpenCV example would be, let's say you have an image, you could do it either import the JPEG, import the camera, and you create an IPL image. And this IPL image is like notoriously known for being the OpenCV image standard. And the funny thing about it is it stores it in blue, green, red, rather than RGB. It's BGR. Something really weird about that. So BGR is just the way these sensors work, right? Is there's 3 sensors for color. There's blue, red, and green. And each of them measures intensity. So you get an intensity value of each one. You overlay that, and now you have an image. What we're going to do is you convert that over, and this is what I'm about to do is just basic color recognition of an object. So I can like hold up something that's green, and this is the background and everything, and it'll recognize and make a contour of, hey, this is a green object I see. That's what all this is about to do. Then you convert it to HSV, which is hue, which is the actual true color, saturation, which is the amount of color that is actually there, and then value, which is the light intensity of it. See, there's like a nice little cone that explains it. Hue is going around, value is up and down, and saturation is from the center out. This is a really easy way to deal with it, because now you have hue, which is the color it sees. And you can tune these variables a lot more easily than having to do it in RGB. Then you can do thresholds. You can, you know, bring the light intensity down of whichever color you're working with. You can erode it. So sometimes when you see these images coming back, there's these little spots it's picking up. You know, random pops on these, you know, pixels going, oh, I see a little green here. Eroding takes away these small contours, these little tiny dots, and kind of makes a and takes the bigger blobs and makes them a little bit smaller, so sometimes you have to dilate and make the bigger surfaces you've discovered bigger, but your tiny objects have gone away. This is a lot easier to explain if I had a live demo video for that, but I don't. And then you take, once you have the colors that you've discovered, there's literally a function, something like, actually go to the next slide. Somewhere in there, yeah, I posted the code, you can look at it later. There's like CV find contours, and you give it the image, and then it draws the images for you on that image. And if you go to the next slide, I think, these are the links, you can look at them later. This is source. So here's me with a cup on my head, and I'm holding a multimeter. And over here are all the variables I tuned. So the hue is like 146, which is red-ish. And I chose the band of what, how much red am I willing to accept. There's saturation, like how dark is it? It's fairly dark actually. And then the value of the light intensity. And then it recognized it and I said, draw the contours where you see red, and there's red. Then I can say, which I did in this example, choose the largest contour, find the center of it, and now you know the center of that object, and you know where it is. You can move it around the screen, and it's telling you it's here, it's here, it's here. Next slide. Kinect, though, gives you something even cooler. This is a vision. This is at night, so you can barely see me in the picture, obviously. But then, this is actually a really good example, because you can see that the vision's failing you, but the depth is telling you where I am. So you can see my glasses, you can see my face, you can see my chair, and then beyond is, probably somewhere in my room. I don't know. But that's very valuable. That's extremely valuable, because now you can navigate, and your color image might tell you something else, but your depth is telling you there's something there. Look out for it. And what's even greater is you can take all this information, next slide, and you can project a three-dimensional image, field of where everything is in a point cloud. And this is what I'm about to demo. You could rotate this, look at it, you could aim it at different places. Downside is you can see I've stuck my arm out, right? These IR projections are hitting my arm, but not, and some of them are going past and it's casting a shadow. So you could only see everything in front of you. And like if he was there, standing there, and there was someone behind him, I couldn't tell if there was something behind him. So that's one downside, but you're only at one point, so you can only solve for that field of view that you get.
How would you circumvent that problem?
Two kinects, I haven't done it. I've heard it works sort of, because the kinects can confuse each other. Like, is that my dot or your dot? Yeah. There's different ways of doing it. So the one way you would do it is have two of them. But if you had one, there's actually a really neat way, and I wish I put that slide in there, so it's a good question. What you can do is recognize points of interest. So you'll recognize a corner of that table and the corner of that table, and you know the depth is there, you know that object is there, and then you run it through an integrator. So it keeps integrating and going, okay, the objects are there, they're staying there. It adds to the confidence of that object actually being there. So when you start moving around, it'll recognize the points before, and then when you move to the next frame, it'll go, oh, I remember those points, and snap it and go, cool. Hey, I see more of it now, and I'll add that to it. And it starts, as you run that and move around, there's a really good YouTube video of this. And they moved around, and now you have a full, you've pretty much scanned it and used, point of interest recognition, and now you have a 3D plot of the entire table. Next slide. Demo. Actually, I have one more slide, and then we'll do the demo. So you get, like, I don't have a DVI cable, so I can't project this. So we're gonna have to come down here. So why is this good? So a lot of those IMUs and things like that are very, very powerful in that they can tell you how the object is oriented, but actually knowing if you're here or here, like translational-wise, X, Y, and Z, you have to integrate your sensors and kind of like, how we went to the moon, they had like a gimbal that would record every single movement, and it would figure out how far they've gone, but that can drift. And they actually had like, a star finder where they used, 2 stars and figured out where they actually were and figured out position from there. So you can have the IMU, but it's not good enough. And GPS doesn't work indoors. So like GPS right now will tell you you're somewhere else, maybe even across the campus because the signal's all, weird. So with the camera, you can finally say, okay, I know exactly how I'm oriented, but I can also figure out where I am in the room and how far I've traveled. And you feed that back into the sensors, and you can do all sorts of crazy, crazy stuff. And then later you can feed that into a pathfinding algorithm. You know you're on the ground. You know you're not moving. You can see you want to go there. There's all sorts of algorithms to find how to move from here to here. That's like a whole freaking stuff. Yeah. So I can do a demo now. They're probably gonna have to come up here though.
So I think what we're gonna do is we're gonna go ahead and have it just set up here. So thanks for coming. If you want to see the demo, go ahead and come up. And yeah, thanks guys.
Thank you.